Have you any, have you any doubt regarding that in lesson number 1, or we just move on to lesson number 2?
Just a minute. Just let me go through the chapter. I'll tell you if I have any doubt.
Okay. Do you want me to give a quick revision of the chapter?
Yes, ma'am. We can do a quick revision. Yes, ma'am.
Yeah, we can have a quick revision. So we started with the periodic table, the lesson number 1. In lesson number 1, we studied about majorly on a whole about the 4 scientists. The first one was a Dobrinier, the second one was Newland, the third one was Mendeleev, and the fourth one was Moseley. Right? The Dobrinier arranged the elements in the group of 3. What do we called the group of 3?
Tracks.
Tracks. Good.
Tracks.
Then came the Newland. Why does the Dobrinier model fail? Because it does not hold for all the elements, right? Then
Yes.
we have Newland. So Newland arranged the elements in the increasing order of what?
Atomic weights.
Atomic weights. Good. But also there was a failure of this model, Newland's model, that elements were repeatedly the elements were repeated and also some spaces were left which was undiscovered. Then we have Mendeleev and then we have Moseley. So we are coming straight towards the Moseley. So Moseley arranged the elements in the increasing order of their
Atomic number.
atomic number. Okay. And what did he name his periodic table? The modern periodic table. Right?
Table.
So total till today we have 118 elements arranged in the form of rows and columns. Right. Okay, so what do we call the columns in a table of
Excuse me,
periodic
ma'am.
table? Yes.
Ma'am, how we have defined that K shell, N shell, whatever, has only this type of, like the first shell has a capacity of 2 electrons, and then as you move further, like we have the formula. How does that formula write? Like, what's the
This,
logic of it?
yeah, we'll give the logic in the second chapter. We have this in the second chapter detailed.
Okay.
Yes. So in the periodic table, what do we call the rows and the columns? What do we give a particular name to them?
The rows are known as periods, and the columns are known as groups.
Okay.
I think I
Good.
did. Yes, it's correct.
Okay, and what does the period signifies?
The period signifies the number of valence electrons in an atom.
Valence electron in an atom. And how many periods are present in periodic table?
18
There are not 18 periods.
or 7. Sorry, 7.
Yes, 7 periods. And
And
what does the group?
period signifies the number of shells. Sorry, not the valence.
Yes, that also I was just going to point you out. And what does the group signify as?
Group signifies the number of valence electrons. And
Yes,
the
number of valence. Like how many groups are present in periodic table?
18.
18. Good. Okay, what is the similarity when we move across a group? What is the similarity we see when we are
When
moving across a group?
when we are moving across a group, that is from left to right, the number of shells remains
Hmm.
same
We are
throughout.
talking about group top to
Then
bottom.
the valency, that is the valence electron.
Yeah, the valence electron remains same. Okay. What do we call the name of the first and the second group? Which group metals?
The first group is the alkali metals, and the second group is the alkaline earth metals.
Okay. And the center metals from the group 3 to group 12 are
Transition elements,
transition elements. And towards the left hand side, we have metals, and towards the right hand side, we have
non-metals.
non-metals. The last 18 group, which is known as
Uh, Noble gases,
noble gases. And the 17th is known as
halogens.
halogen. Halogens have which character? Electropositive or electronegative?
They are the most electronegative in character.
Oh, yes, they are the most electronegative. Okay. What is the special characteristics that bridge elements possess? Can you give an
The
example?
the bridge elements are the elements which are similar in properties and characteristics diagonally. For example, elements of period 3 and uh, period 2 and period 3. For example, if you
Can
take the
you name the
element,
element? Yeah.
the properties of magnesium are similar with lithium, and properties of aluminum with beryllium, and silicon with boron.
Yeah, diagonally.
Yes,
Okay.
diagonally like this.
Yes, the group 1 and 2, we considered them as metals. So, can you tell me the metals? They can be converted into sheets or wires or both.
Sheets or wires both. They are malleable and ductile. both.
Yeah, they are malleable and ductile. And what about the conductivity of the metals and non-metals?
Metals are highly conductive because they have a lot of they have electrons to conduct electricity. They're good
Yes,
conductors of electricity.
you can say electrons also, you can say free electron also. Both are correct. In
Yes.
some books, free electrons are also written there. Okay. Among
In
the
Dalal,
group,
I think only electrons is there
yes,
given.
the line we have, yes. Okay, between the group 1 and group 17, which are good reducing agent?
Group one because they are metals.
No, this is not the reason they are metals.
Group ones are reducing agent because they donate electrons to
Yes, they do not
non-metals.
electrons. Yes. And group 17 are oxidizing agents because they are electron
Because
acceptors.
they accept electrons given by group one elements.
Okay. So how do we define the periodicity of
Uh,
element?
we define periodicity of the elements as regular properties that arrive in the periodic table as we move from the period left to right and down the group top to bottom because of the similar characteristics and properties of the elements in certain groups and periods.
Good. How do we arrange the periodic table in the increasing order of their atomic
Number.
numbers? Okay. Now I'm coming towards the definition. The first definition is of atomic radius. It is the distance between the center of the nucleus and the
Outermost shell to the
of an
outermost shell.
atom. Good. Talking about the ionization potential and electron affinity. Give difference between the both.
Ionization potential is the amount of energy needed to remove an electron from a gaseous atom, and electron
Yes.
affinity is the amount of energy released when an atom is really put into the gaseous atom.
Okay.
Ionization, yes, that only.
Okay. In ionization, between ionization potential and electron affinity, which accepts the electron? Ionization potential or in the
Electron
case of
affinity,
electron? Okay. Talking about the electronegativity, it is a tendency of an atom to what?
pull electrons towards itself when it is combined in a covalent bond.
Okay. So when we are talking about the group, what does the atomic, how does the atomic radius affect when we are moving left to right in a period?
When we are moving left to right in a period, the atomic number increases, and that is why the nuclear charge also increases, which decreases the size of an atom. So overall radius decreases, atomic
Yes.
radius
Yes. And in the case of groups, when we are talking about the group, the atomic radius tends to increase
increase,
because the number of shells are.
increasing, and nuclear charge is also increasing, but the number of shells are increasing dominates over the increasing of the nuclear charge.
Yes, the nuclear charge reason goes with every question that comes.
Yes,
Talking,
almost
yes,
the shells also for electron affinity and those
yeah.
things.
The main summary of the chapter is the shells and the valence electron, only these two. Okay, in terms of ionization potential, when we are talking about the group moving from top to bottom, how does the ionization potential affects down a group?
And down a group, as we move down the group, the atomic radius increases and the nuclear charge increases, and so overall ionization potential decreases down the group
Okay, okay, okay. That's nice. The element helium has the highest ionization potential, while the cesium has the lowest. Why is it so?
because as we move from left to what was the question again?
Let me repeat the question. The element helium, which is a Nobel group, has the highest ionization potential, while on the other hand, the cesium metal has the lowest. Why is it so?
Because as we move down the group, the ionization potential decreases.
Okay. And the
And
ionization
again,
potential
helium is a noble gas and cesium is in metal. Like
is a
it has
metal, right?
unstable electronic configuration.
Mm, okay. In terms of ionization potential, also you can define that they have low ionization potential as compared to non-metals or noble gases. Noble gases are just stable. Okay,
Yes.
when we are talking about the electron affinity, the unit of electron affinity is
Angstrom. 1 angstrom is equal to 10 to the power of minus 10 meter, and picometer is also a unit, which is equal to 10 to the power of minus 12 meter.
also we can say electron volt also, EV.
Yes, same electron volt also.
Yes, EV
One
also.
one electron volt is equal to how many meters of angstrom?
No, you can define in terms of angstrom because EV is the unit of electron volt, means they both are the different parameters. EV and meters. Like if I say about the liters and kilometers, they both are the different parameters. So EV
Yes.
and meters are different parameters.
I
We
think
don't,
electron volt is a unit to measure the amount of energy transferred during electrons spins or quantum
yes,
related stuff.
amount of
It's
energy
it's not
released.
it's not the unit which we are looking for. It's not for ionization potential, I think.
Yes, it's look in Dalal book it is written that the unit of ionization potential is electron volt, but we can measure in other quantities also, like you told angstrom, and like similarly the atomic radius, which is generally
It is
measured in
written.
nanometers. Yeah. So you should, I guess, you should follow your book in terms of the
Yeah,
answer. Okay.
because it is
Electro
prescribed by the board, so we should,
the
I
board,
guess we
yeah.
should.
Hmm. The electron affinity from left to right, how does it affects the periodic table from moving left to right?
Electron affinity. As we move from left to right, the atomic size increases and the nuclear charge also increases. So overall, the atomic size decreases, and that is why the electron affinity increases.
Why the electron affinity of halogens is highest and least for alkali metals?
Electron affinity for halogens is highest because they are the most electronegative elements, and they have only one seven. They have seven side in their outermost
Shell.
shell, so they have
Yes.
a tendency to acquire one shell to become stable.
Okay. And if you're talking about neon, it has zero electron affinity. Why is it so?
Yeah, electron affinity is the tendency to acquire electrons when combining an equivalent bond. Neon is a noble gas, so it won't form any compounds, so it has zero electron affinity. And it won't. It has a stable electronic configuration, so it does not have a tendency to gain or lose any atoms.
Okay, good. Okay. When we are talking about down a group, then what is it's yeah, are you there? Mm,
Yes, ma'am. I got disconnected. I think.
yeah, I think the connection was interrupted. Okay, when we
Yes.
are talking, let's resume. We were talking about electron affinity. In terms of electron affinity, when we are talking down a group, the electron affinity
It
decreases
decreases.
because the atomic radius. What does atomic
At,
radius mean?
because the atomic radius decreases with the increase in with the increase in atomic number and increase in nuclear size, so overall atomic radius is increased, which results in the decrease of ionization potential.
Okay. In talking about in terms of metallic and non-metallic character, when we are moving from left to right across a period, the non-metallic character increases or decreases?
From left to right in a period,
Yes, in a period.
non-metallic character decreases.
No, when we are moving from left to right, we are talking
Increases,
about,
increases. Sorry, increases,
yes, it increases because the atomic radius increases or decreases?
decreases. Atomic radius decreases.
Decreases. Okay. When we are talking about down a group, the metallic character increases or decreases?
Increases. Down a group, it increases.
Increases. Okay. So elements at the bottom of the group are most metallic and they have large
Yes.
atomic size and lowest ionization potential, and thus they can easily just form metal most readily. Okay. In terms of electronegativity, the elements with high electronegativity being usually non-metals. Why is it so?
because they tend to accept the electrons donated by the electropositive metals, that is metallic elements. Alkali group 1 and group 2 metals. Alkali metals and alkaline earth metals.
Yeah, more easily. Okay. Good. Just then we have just completed. It's just last page, the physical and the chemical properties, and we have just
Yes.
moved into. Okay, so for second chapter, you might need a register and a pen because you would be drawing some diagrams, and you also would be drawing. I will just teach you to draw one, and similarly, you will draw all of its types. Okay,
Yes,
so
ma'am.
this was all about our lesson number one. Now we are going to start our lesson number two, that is chemical bonding. In lesson number one, we read about the periodic table that different elements are arranged according to periods. We learn about the valence electron, valence shell, and the free electrons, the metallic and non-metallic character. Now, in this chapter, you are going to learn that how an element forms bond with the another kind of elements, how they both are related. For
Bond
example,
means?
yeah, that only I'm going to explain you. For example, if you're talking about a single element, elements are always single. Well, they are composed of very small particles that we call atoms. So in
Yes,
periodic
ma'am.
table, we have seen all the elements were individually arranged. Like helium has been given position 2, hydrogen has been given position 1. But as we have seen, the name of certain compound like sodium chloride is turned as common salt, NaCl. Now,
Yes,
NaCl is not a single element in the periodic table. We can see that Na lies in the group 1 and Cl lies in the group 17. So, what is there in between two elements? How they are going to get pair up? What are the structures of the atom? Because we know that the elements are composed of very small particles called atom. So, what how the structure is arranged, that Na combines with Cl. Not only NaCl, you are going to learn about different structure, different compounds. We would say compounds because elements are individually arranged and compounds are formed from the elements.
yes, ma'am. Just a minute, just let me get the textbook. Just
Okay.
yes, ma'am.
Okay. So we are on page number 21 if, of your book, right? In page number 21, the first heading that has been given to you is the atom. Now, according to the structure of atom, which we have read, that an atom contain the center spherical model that is known as nucleus. Inside the
Yes,
nucleus, we have read about the three subatomic particles in class 9. So I'm just assuming that you know all the content of the class 9, right?
yes, ma'am.
So we have three subatomic particles that we name as proton, electron, and neutron. So proton carry positive charge, neutron carry neutral or no charge, and electron carry the negative charge. Inside the atom, the all the three subparticles are arranged. Now, as you can see, an atom contains a center which is called nucleus. Inside the nucleus, two of the subatomic particles are arranged, which are protons and neutrons. Then we have electrons which revolves outside the nucleus. So if any kind of question comes between the difference between talking about the difference between electron, proton and neutron, the first point you can give is their charges. That electron carry negative charge, the proton positive, and neutron carry no charge.
Ma'am,
Second
is
point,
the angle alpha also differed when we as moving across the, what do we say, shells and the
no,
partial derivatives value?
alpha is not referred when we are talking in general in terms. When we will talk about the because just now we are just learning about the formation of compounds. So, from in formation of compounds, no theta and no angle is being referred in class 10th. In
No,
11th, you
I'm talking in general. Does it refer? Not in 10th or 11th, 12th? Just
no, in
question.
general, we don't refer theta and an angle. No.
But according to equations, it should differ because
Yeah, it should differ, but according to the syllabus we are talking about, it does not include that is not included in the books. From higher classes it is included, not in 10th. That's why I'm just talking you about again and again. In general we don't consider, because in class 10th we are just reading about the basic. If it would have been important, then it would have come in class 10th, but it is not included in the book. Not even just a reference is given about theta or at angle.
And equations are also not included, obviously.
Yes. Okay. So when we are reading about the structure of an atom, we know the inside the atom holds a center which is known as the nucleus. Inside the nucleus,
Yes.
two of the subatomic particles are placed, which are proton and neutron, then which are placed inside the nucleus. We have just electron left, which revolves around the nucleus. Right now in this chapter, as I told you, we are just going to learn about the formation of the compounds, that how the metallic character, your metallic elements is forming the bond, forming the pair, not bond you will learn after few headings, how the metallic nature is forming the bond with the non-metallic nature, non-metallic character, or non-metallic element. So thus about the structure of atom you understood very well, the electron, proton, neutron. Then about the when we are talking about the types of elements, in periodic table we have learned that there are two types of elements. The first category include the metallic elements, and the second include the non-metallic elements. And also now you know the position also. The metallic elements, they are arranged in the group 1 and 2 most probably,
Yes.
and the non-metallic are arranged from the group 13 to 18 or 17 you can say. Or most precisely if you will talk, the metallic are arranged
In
or two.
in group one, two, and I think in group
12 also you can say, because the transition are also the metals, they are not non-metals.
yes.
Hmm. More precisely, if we talk about the position, the metals are arranged on the left hand side and at the center, and the non-metals are arranged towards the right hand side. Now,
Group 3 to 12 are not metals, right?
no, they are metal, transition metals, they are not non-metals.
So they are metals,
Yes, they are metals, transition metals.
but they are not as active as group 1.
They have just unique properties from 1 and 2. For example, if I just describe among a single, I just tell you, then group 1 and 2, they readily dissolve in water. But when we are talking about the group 3 to 13, we have, if you talk about iron, then iron does not dissolve in water, it reacts with water.
And form
Similarly,
the rust.
yes, that forms rust. Similarly, if you talk about nickel and cobalt, they just emit radiation or the color or the transition. But similarly, sodium and all group 1 and 2, they does not show such kind of transition. So their properties are totally different, but we put in the category of the metals as a whole. Now we are just going to learn, these are the two headings that we have learned from lesson number 1. Now we are moving towards the chapter. Now the formation of the compounds. When we are talking about the formation can be done in two ways. The first one, as you know, the metals I have the electropositive character, and the non-metals carry the electronegative character. Also, you read about the electronegativity. It is a tendency of an atom or electron to attract towards itself. So, when it is attracting towards itself, it can be done by two ways. What are the two ways? Either the non-metal or the electronegative element can just share its electron with each other. The electronegative element which accept an electron, right? So when it is accepting an electron, it can be done by two ways. Either it can share the electron or it can transfer the electron. In both the cases, the electron will be given to the electronegative group. Either we are sharing, sharing means one already have, and two other we are also sharing. And when we are talking about transfer, it means that one is giving entirely to the other element, right? In both the cases, the electron is being accepted by the other element, right? So in this chapter we are going to learn about the formation of compound in two ways. The first one is known as a transfer, and what kind, which electron we would use for the transfer? The outermost shell, the valence electron, right? Secondly, the other way to share or other way to form the bond is known as the sharing of electron. The transfer and the sharing, there are just two cases in which the atoms can combine with the other atom. Okay, now talking towards the definition, the first definition, that again and again we are using a word bond, bond, right? Now I'm going to explain the term bond. Since we are reading in terms of chemistry and we would be talking about some compounds, the bond is generally termed as the chemical bond, or also you can say it as a normally bond, or you can say chemical bonding. All the three names are correct. It's just method to describe. Now, how do we define a chemical bond? The chemical bond is defined as the force. Suppose I took an example of NaNCl. How this NaCl is linked to each other. This is known as bond. That how the electrons of the sodium are linked with the electron of the chlorine, and this linkage, that is linking to both the elements, this is known as bond. Now this how this bond is formed. This bond is formed, as you know very well, the proton and neutron are just inside the nucleus, they cannot come outside. But the outside, the electron, the valence electron, majorly we will be talking about in the formation of bond, the valence electron. Okay, so how do we define a chemical bond? It is the linkage or the force which is acting between two elements, which is leading together to form a stable configuration. You know very well that why these bond, why we are forming the compounds, so that both may attain a stable configuration. Why we are not forming bond of the noble gases? Because they're already stable, they don't need to just give or take electrons, right? So I
So, ma'am, excuse me,
yeah.
ma'am. Ma'am, so basically the reason for reacting is to attain stable configuration, right?
Yes, the basic reason why we are forming such bond, why we are forming the bringing two elements and making them pair with each other, is to form the stable electron configuration. Also, we cannot pair any two elements. Like sodium, I cannot pair with potassium because they both
Well,
are
why?
metals.
Oh,
Yeah, that
metallic.
yeah. Suppose I'm taking sodium and suppose I'm taking potassium. They both are metals. So what? They both are metals. They also can be paired, but they both what do they both have they but the characteristic of metal is that they tends to lose the electron, right? So sodium will also lose the electron and potassium will also lose the electron. So if both are losing the electron, they cannot form the stable configuration. This in detail we are going to study, that what is the complete logic, that why they cannot form, right? And also we are
Yes,
talking in terms of noble gases. As I told you, the noble gases already their electronic configuration is complete. They have complete outermost shell, so they don't need to become stable because they're already stable. Okay. And
yes,
also,
ma'am.
just remember the two ways the in majorly paper in paper question comes, that what are the modes or what are the methods to achieve the stable electronic configuration. So first one is by the electron transfer, and the electron would be transfer only from the valence electron. Not all the electrons would participate, right? For example, if we are talking about sodium, sodium has 11 electron. Not all this electron 11 electron are going to participate in the formation of compound, right? Similarly, if you're talking about chlorine, not only all the 17 elements are going to participate, 17 electrons. Then this we are going to learn that how many electrons would be required, how many electrons would be responsible. Okay. Now let me just explain you about the shells you were talking about, the your major concern related to that topic. Now we know very well that and nucleus they contain proton and neutron, right? Also a diagram, maybe a question can come that draw the structure of an atom with three shells or draw the structure of atom with two shells, right? So this is the nucleus. If it is asking you for the two shells, you should use a compass. I'm just drawing merely with hand rough diagram. So if it is asking you with the two shells, then you need to draw the two orbits. If it is asking you for the three shells, an energy level diagram or the structure of an atom with the three shells. So this is the three shells. How do we name these shells? The naming start from the K, the alphabet K. The first shell is known as K, the second shell is known as L, and M, and so on. Now, what rule do we follow to fill the electrons in these orbits? Right? Now you see the formula which we use is 2n square. The simple 2n square formula, simple basic maths. If I'm talking about K shell, then if I take the value of n, if I would be taking 0, then everything will be 0. There would be no electron. And there is no possible, and there is also not possible an atom without an electron. Even the hydrogen have single electron inside it.
So ma'am,
right?
my question is, how did this derivation come? Like, how why only 2n? Why not 5n, 4n, or 6n, or 3n? Why only 2n?
It is 2n
Uh,
because there was a scientist Bohr. In class 9, we have read about the three models. The first model was a Thomson's model, the second was a Rutherford model, and the third was a Bohr's model. So the drawback of the Thomson model was that he just explained that atom is electrically neutral. He just told that the magnitude of the positive electron is equal to the negative electron, which he proved. But he does not give the evidences. He compared the structure of an atom with a watermelon, if you remember. Let me just revise you. So he said that the pink part of the watermelon, like the watermelon, the entire part of the watermelon is pink. So the pink part contains the positive electron, which is outside the sphere. And as you know, the watermelon contains seeds, the black seeds, which are distributed among the watermelon. So he called the seeds as the negative electron. Right. So this model failed because of the first postulate that the positive electrons are embedded inside the negative electron. Then we have the second scientist, Rutherford. So Rutherford
so
just
positive electron, negative electron, they will just interact and the atom would collapse. It makes no
not
sense.
collapse. It would be electrically neutral. It would not collapse because in his second postulate he told that the magnitude of the positive and the negative is equal. This he proved very well. But according to his first postulate, the positive charge is outside the sphere and the negative inside. So conversely, we can say that negative may be inside the positive. There is no such evidence of the first postulate, right? So this first postulate was redefined by the second scientist, Rutherford. The Rutherford model is quite long. I'm just talking in a nutshell. So Rutherford model failed because his model failed to explain the stability of electron. How it failed to say stability of electron? The Rutherford model said that there is a nucleus and positive charge is there and electron is revolving. Right. The cause of the Rutherford model failure was that when he told that the electron keeps on revolving around these orbits, right? Till now it is clear.
Yes.
But when an electron is revolving, it must have certain speed with it. It must be revolving with a certain speed. He must be revolving certain within certain acceleration when it is revolving. And also, it must radiate some energy. So if we follow the third point that it must radiate energy, so there must be a point when the energy will be quite low while revolving. So if I'm talking about the three shells, the electron would revolve in the third shell. If its energy would become low, it would come to the jump to the second shell. If its energy becomes low, it would jump to the first shell. And if at a certain point its energy will be quite low, that it would just go inside the nucleus. But overall this stability was not explained by the Rutherford. And then your question comes, then who gave the formula 2n square? There was a scientist Bohr. Now Bohr said that there are certain discrete orbits in which the electrons revolve. Also he was a scientist who gave the concept of the shells and the formula 2n square, right? The form why he gave 2 and why he gave n square, that I will explain you later, because I want to complete this topic. I'll explain you in the last 5 minutes, okay? So the formula while filling the shell is 2n square. We will, if you will take n is equal to 0, then entire thing will be 0, right? And there is no atom without a single electron. Even the hydrogen contain one electron, right? So when we are taking the value 1, so when n is 1, then 1 square is 1 and 1 into 2 is 2. That's why we follow that in K shell maximum 2 electron must be completed. When we are talking
And
about,
that's
yes, when
and
we are
that's
talking,
still fine, but that still does not answer that why only 2n or why only n square. How does this equation come for the matter of fact?
yes, I would explain you how does the equation come for the matter of fact, because it would take quite long time. It would take hardly 20, it would take 20 to 25 minutes to explain the complete derivation of that topic. I'll just prepare for you in a nutshell in the next class in a short way. Okay.
Yes.
Okay, I will answer your question, but in the next class because that is quite long. I'm not just delaying you with the thing you asked me. So the first shell, as I gave you the formula 2n square. In 2n square, when we are taking about when n is equal to 1. So when we are taking n is equal to 1, there should be 2 into 1 square. 1 square we know it is already 1, so it will be 2 into 1, that will be 2. So K shell can have maximum how many electrons? It can have maximum 2 electrons. Similarly, when we are talking about the L shell, L has n is equal to 2 value. If we are taking 2 twos are 4, similarly, when we will put 2, it will be 2 square, 2 into
8.
4, that will be 8. Similarly, for the M shell, KLM, for M we can have 18, and for the N we would have 32, right?
N is 4 in the first case, right?
N is 1 in the first case, K shell. In L, we
Yes,
have taken N is equal to 2, and then we have taken N
yes,
is equal to 3, and N
3,
is equal to
yes, yes, yes,
4.
okay. Yes.
Now, let me just explain you that we were talking about the bond. That what is the bond? I just told you the linkage between the two elements, the force which is holding the two elements together, that is known as the bond, right? So, as you can say, when the bond is formed between, as you know, the positive and positive will already repel. Similarly, the negative negative would repel, right? So, to form a bond between any two element, the positive must hold with the negative one. Right. And we know very well the positive character is held by the metals and the negative character is generally carried out by the non-metals. Right. So here comes a definition, another definition of the bond, that the bond is formed between a metal and a non-metal. We are not talking about the state, whether it is a solid or a liquid or a gas. We are just talking about individually of an element, that a bond is formed between a metal and a non-metal. And why is it so only metal and a non-metal? Because the metal have electropositive character and non-metal have electronegative character. The metal with it generally tends to lose, and the non-metal generally tends to gains. Any problem till here?
No, no.
Okay. Now the first formation which I'm going to tell you is about the sodium chloride. The symbol of sodium is Na, and the symbol for chloride or chlorine is Cl. Talking in terms of atomic numbers, the sodium carries atomic number 11, right? And the chlorine carries atomic number 17. The first structure I'm telling you, the rest of the structure you would be drawing. So listen and look very carefully. Now we would draw the electronic configuration. We are just drawing the shells. This is a K shell, and L shell, and M shell. We don't require M shell, I guess. So the first K shell can have maximum 2 electrons. So we have filled in maximum 2 electrons. So from the 11, 2 electrons are being filled, right? Now we have how many? 9 electrons left. Are you audible? Am I audible?
Yes, ma'am.
Okay. So in the K shell, as you can see, we have filled the 2 electrons. Then we have in L shell, we can fill maximum 8 electron. So here we have filled maximum 8 electron. Total we have just 10, and we have to fill 11. So one is left. So one is jumping towards the third shell, right? Similarly, in the case of chlorine, the first shell is having 2 electron. The second would have 8, and we have just filled 10 electron. The 7 are still left here. So at the last shell, 7 electron will come. This is the first step of the formation. What is the first step? To write the electronic configuration. Here we have done completed our first step. Now coming towards our second step. Our second step include the ionic equation, that how we are going to show that what is going to happen with the each element, right? When we are talking about sodium, was the sodium which was 281. So it has one electron in the outermost shell. As I told you, not all the electrons are going to participate. Only the valence electron will participate. So here the valence electron includes the outermost electron in a shell. So here the valence electron is 1. So to make the sodium stable, it need to lose one electron, right? So when it is losing one electron, we are showing with the help of equation like this. Now what this equation is denoting, that the sodium which was having 281 has lost its one electron to become stable. So here now it has become 2 comma 8.
Ma'am, excuse me, ma'am.
Yes.
Ma'am, the properties of an element depend upon the equation, morely on the last shell, right?
Only on the valence electron, not on the shell, on the valence electron.
So, ma'am, sodium is turning into neon. It will have the properties of neon, which
Mm,
sodium
Definitely
loses
not.
its character. Then how is that sodium chloride? It's not neon
Yeah.
chloride, and that
Now,
does not make sense.
yeah. Now listen. Sodium was originally having 11 electrons, right? It lost one electron. It does not turn into sodium helium. Look, Sodium was having 11 electron, it lost one electron, and now it is 2 comma 8. But still it is
Yes,
2
ma'am,
comma
understood.
8. Yeah, still it is 2 comma 8. I have not given it the name neon. It's still the sodium. Now what you need to understand is here it was the sodium metal which we took, and when it lost one electron it became 2 comma 8. It became sodium ion. Now what is an ion? Ion is the charged species. Why I have not written here neon? Because the neon also have electronic configuration 2 comma 8 originally. Like, now it does not require to lose or gain electron, and what we have done here is we have converted a sodium metal into an ion, and that's why we are not writing helium neon here. Okay, this positive has its particular symbol. This positive is denoting that from 281 it has become 2 comma 8, or in a more precise way you can write plus 1, showing that it is formed after losing its one electron.
Ma'am, why only 8 is considered as the full electron shell? Because if you take elements like if you take higher elements which have more than which have six shells or seven shells, we have the seven shell as capacity. I think seven square into two, like 49 into two, right?
Yes.
So why only 8? Why only second shell? Like that's for 2 square into 2, that's 8 considered as a valence shell or the full octet rule.
No, basically, we are talking about the maximum capacity, that atomic radius we learned while reading the trends. So the atomic radius we define the center of the nucleus
Why is
will be.
not 152 considered? That's 49 into 2.
Can you just repeat a little bit slow?
Why is not 158 considered? That's 49 into 2. Why is it not considered?
You can take it along, like we have started at KLMN, it can go up to OPQRS also in class 10. When you will go in class 11, when you will read about the higher elements, for example, just now we are just reading till 1 to 20, 25, or maximum 30, right? When you will go to class 11, these KLMN shells have been given the other name by the it has been made a level up. Like right now we are studying in terms of KLMN shells, right? When you will go to class 11, these k element shell has been renamed, and they have been given the name of the spdf orbitals. Means in class 11 the entire filling would be different for the higher elements. For the lower elements it would be the same up to 25 or 30. But as I told you, if you're learning about the higher elements, like if you're going 49, 59, or if you're reading about the group 7 or the group 8, sorry, period 7 or period 8, which have quite large atomic numbers, then you would be following the spdf rule. This rule is quite different from this k element shell rule.
Ma'am, if we take like the basic which we are taught at which level, the k element shell, the electron spins, it would be different for every electron, and it would be expressed as delta x by x naught plus delta x plus delta y plus y naught, which would contradict the original balanced first electron shell would have delta y dash plus delta y dash naught plus delta y dash plus delta x naught dash. So how is that possible? According to the 10th standard syllabus, it would be contradictory.
Could you just write down the, you're talking about the same equation which you gave me the day before?
No, ma'am, this is different. This is for electron spins.
No, when you're talking about the spin of the electron, then the electron spins clockwise and anti-clockwise in both the directions, right?
Yes.
So, and also when we are talking about the spins, then we define the spin of the electron in terms of plus half and minus half, right? So, as we say that the atom is electrically neutral, so when an electron spins, so half of its movement is towards the clockwise and half of the movement is towards the anti-clockwise, right? So there is no d5 on
How is
d5.
that? How is that possible? If electron revolves, it has to revolve as an Anti-clockwise electron will break apart. It would result in atoms breaking apart,
It
and
this
it does not
concept
make
of
sense.
yeah, this concept of clockwise and anti-clockwise spin has been given to you in these spdf orbitals of class 11th. In the you will read a topic which is known as quantum numbers. In that there are majorly four quantum numbers you study in class 11: the azimuthal quantum number, the four magnetic quantum number, and similarly there are four quantum numbers. And in that topic particularly, you read about the spin, you read about the magnetic moment which it carry, and also the angle which you are talking about, the theta. In that topic it has been clearly explained all the four concepts related to the structure of the atom.
Okay, ma'am. Yes, ma'am.
Okay, so I was talking about the formation of sodium chloride. In sodium, as I told you, we have the first step is to write the electronic configuration that we have done. We are showing it in the form of equation. So sodium is 281. When it lost one electron, then it has formed Na positive one, showing that from it has formed from 281 to 28. Similarly, when we are talking about chlorine, the chlorine has atomic number 17, so it is 287, and it needs to gain one electron. So I'm showing it with the help of positive one. And now, since it has gained one electron, so it is showing it, we would show it by minus one, denoting the minus denotes that it is accepted, and one denotes that it is accepting one electron. So from 287, it has become 2 comma 8, 288. Now this is the attained noble gas configuration, right? This was the first step, and this is the second step we did. Coming towards our last step, the last step is the form is the to show this formation in the form of orbit structure. Now, as I told you, only the valence shell is going to participate. Either you can draw the valence shell, or also you can draw the complete shell. Now, for example, if I'm drawing sodium here and I'm drawing chlorine here, right? Sodium has atomic number 2 comma 2 8 and 1. Chlorine has 2 8 7, right? So one electron it is giving to him, and one electron is accepting. So as I told you, the two modes of formation of bond, by sharing and by transfer. So the current mode I am just talking about is the case of sharing, or is it a case of transfer?
Transfer.
Yes, it is the case of transfer. So thus the resultant formation is the case of transfer. This is the first case we are talking about. Now if we have to show in terms of electron dot structure, then this is the sodium. Sodium has valence electron 1, which I have denoted it with a single dot. Similarly, chlorine has 7 electron in its outermost shell, 3, 4, 5, 6, 7. It has transferred it electron. Now the resultant compound is Na, which is stable, positive, because it has given its one electron, and after giving it has become plus. And chlorine, it has gained electrons, so it is 1 2 3 4 5 6 7. And the one electron which has gained, I'm showing it with the help of a cross. And how we are going to express this Cl by 1 minus, showing that it has accepted one electron, right? And the resultant is our NaCl. And why this
Excuse me, ma'am.
NaCl?
Ma'am, why does the only positive charge develop when they lose electrons? Like if the delta T upon the partial derivative of y upon partial derivative of T with psi to the power of m plus delta, according to that equation, it should be opposite.
But in that case, we have to put the limits also. Just for right now,
Limit as.
limit as you have just taken the differentiation with respect to m.
Yes.
With respect to m, you just understood what I am just trying to say. That with you have done dy upon dt with respect to m. I'm talking about the this one. If you are doing the integration,
Derivation of differentiation of y with respect to x. That's
yes,
ddx upon yes.
yes, differentiation
Divide
of
it.
y with
Yes.
respect to x. Yeah.
Y
So
with
if
respect.
in your case, when you told you are just asking,
This is
you
an
just
undefined integral.
yes, this is an undefined integral that only I'm taking talking about. When you're in your question which you told me, we have to just define it under a certain limit, the lower limit and the upper limit.
Yes.
So in general we can just undefine it, but when we're talking about something specific, we just to give them a proper limit, the upper limit and the lower
We
limit.
need to define it if
Yes,
we want to properly study it.
yes, properly studied as a whole, or in a general way we can just denote it by the simple equation.
Dy upon dx, but what is the function? That's fine. You are finding the integral of dy upon dx, but what will be the function?
That depends upon on the function, whatever function you are taking here. Because for example, if you are taking, for example, you are taking function 2x square, right? And now we are, when we are going to integrate it, so we can just put the limit with respect to taking it with the help of t, doing its partial derivation, right? And then
Yes, and we can use the power rule and chain rule also.
power general rule. Yeah. So this was all about your formation of the NaCl. The last step, this formation include basically two steps, but it depends on the number of question it has been asked. The first step was giving the noble gas configuration. The second step was giving it equation. The third step I told you is the electron dot structure, and the fourth step is that drawing the electron structure or the orbital structure. So now sodium. This is the nucleus of the sodium, and these are the shells, right? Either you can draw the outermost shell, or either you can draw all the three shells. So
Yes.
I'm drawing it outermost shell because three shell would take time. So the valence shell is having the single electron. In terms of chlorine, the valence shell is having the 7 electron. 1 2 3 4 5 6 7. So when it gained 1 electron, now this is a formation that is Na, this is Cl, right? The Na went from Na to 8 1, it gave 1 electron. So it is having now 2, the first shell, and then it has 8, right? Here we are having 8 electron. When we are talking about chlorine, this is the first shell which was having 2 electron. This is the second shell which was carrying 8 electron, and this is the third shell now which has come from 7 to 8 electron. So this is its orbital structure. Talking in terms of the book, the first step was of the noble gas configuration which we have given. Sodium was 281, and we have given it noble gas configuration of neon. Secondly, chlorine, we have given the noble gas configuration of argon. The second step was showing with the help of equation. The sodium gave 1 electron, so it is denoting by the minus sign. And here it is showing plus sign, showing that it has given electron. Similarly, chlorine we have shown. Chlorine is accepting 1 electron, and that's why it is denoting from the minus 1. If you are showing with the help of electron dot structure, we have to draw only just valence shell. So valence electron is just 1 here, and valence electron is just 7 here. So 1 and 7, and it will be just giving and it would be accepting, and that is the resultant NaCl. Why it is NaCl? Why we are not charging here? Because the charges gets cancelled, the plus 1 and the minus 1. And when we are showing with the help of the orbital structure, the outermost, this is the first shell containing 2 electrons, the second shell containing 8 electron, and the third shell containing 1 electron. Similarly, in the case of chlorine, the first shell containing 2 electrons, the second shell containing 8, and the last containing 7. So here we are just learning about the case of transfer of electrons. So one has given it its electron, and we have from 281, we have just 28 with a positive charge. And in the case of chlorine, we have 288 with a negative charge. So this was all about the structure of a single compound which we learn about the sodium chloride. Tomorrow I've just explained you this structure. Tomorrow you would be showing me these structure. So you would carry the register and your pen with you, right? And you have to just speed up also because we have to cover at least 3 or 4 compounds. My target is to complete 3 or 4 compounds in half an hour tomorrow, right? So
Ma'am,
tomorrow,
could you also explain the page 24, that electrovalent bonding once again tomorrow?
okay, page number 224. Yes, I can explain you. In this, I've explained you about the metallic bond. The metals they generally tend to lose 1 electron. One, not one
Yes.
electron, the outermost electron, whatever it is carrying. The non-metals they generally tend to gain electron. That's why it is showing with the help of plus sign, and here it is shown with the help of minus sign. Ions, as I told you, and your question which I've answered, that why we are not writing the noble gas, because they have just formed ion from the metal. After losing or accepting electron, they are forming ions. They are not forming the stable configuration. They are not forming the noble gas, but they are attaining the configuration of noble gas, right? Sodium is not trying to become neon. It is just trying to attain the stable configuration nearest to the neon. Okay. Now the electrovalent ionic bond I explained you already. The bond which we are learning by the transferring of valence electron is termed as electrovalent bond. Coming towards the definition also, you can see the chemical bond which is formed between two atoms by the transfer of one or more electron. In sodium chloride, we just transferred 1 electron. There will be more cases where the more than 1 electron would be required to transfer. Talking about the electrovalency, Now, as you know very well, electrovalency is the tendency of an electron to lose an electron. If we are talking about sodium, the sodium has lost one electron, that is the outermost electron. So the valency of sodium will be 1. And one of what kind? The positive or the negative? The positive one. The positive denotes that the electron has been given. Similarly, if we talk about the electrovalency of chlorine, it will be -1. Why -1? Because it is accepting one electron, right? It would be not 7, it would be 1. Why? Because one electron it is accepting, right? Students generally tend to do a lot of mistake here. In the case of chlorine, they just give the valency of chlorine as 7. It would be not 7, right?
Minus
Thus, valence of
minus
sodium would
one.
be, yeah, the valency of sodium would be 1 because it has just given one electron. And the chlorine will be of 1 because it has gained one electron, right? So this was
Yes,
the topic of your page number 24. You can just read, and whatever you have doubt, you can ask me tomorrow.
yes, ma'am.
Okay. Thank you.